let us listen from the eminent speaker, because concrete is a very important part of the construction industry, and aggregates constitute at least to 60 to 70% of it. So today's topic is very, very relevant to the concrete and the construction industry as a whole. So over to Engineer Kaushikan sir for the further proceedings, please.
Good evening. On behalf of Qcrete Readymix India Private Limited and Mangaluru ICA Center, we welcome our today's eminent speaker, none other than very well known speaker, Mr. N. Venkatesh. Mr. N. Venkatesh is known all over India for his extraordinary works that he has contributed to the field of concrete technology. He is working currently as technical head QAQC in BL Kashyap and Sons Private Limited. He is also chief advisor to Gooly Consultant Private Limited. He has more than 40 years of experience in civil engineering industry. He has guided many projects, professionals implemented in many projects, quality assurance, quality control of construction management, and he is also one of the very well-known experts in the field of ready-mix concrete industry, and he is giving consultancy to many other ready-mix concrete industry professionals also. He has been awarded ACCI National Award for Nagadi winner for best publication of book in 2022. The book is titled as Lessons of Concrete Construction. Very, very well written, compiled, beautifully done book on concrete technology and construction technology. Mr. N. Venkatesh, I can say there are not many books in the Indian construction industry, rather concrete industry in that level. He has done very exhaustive coverage of all the subjects, covering many aspects of concrete technology. So it is very, very good a book for anybody in the field of concrete technology, maybe a junior engineer, a student, or even an expert in concrete technology. He can refer this book written by Mr. N. Venkatesh. And Mr. N. Venkatesh has been giving many lectures in many forms, ICA and otherwise across India. And he has been a great inspiration to many young engineers, especially in the field of concrete technology, also in QAQC in the field of construction. So his CV is very big, and he has done a lot of works, worked in many companies, giving them advice, giving them the suggestions to implement QAQC systems across the construction sector. But due to short of time, we cannot read much about him. I mean to say, it is very short time, I can say. With this, I can welcome Mr. Venkatesh sir. He's also kind of an advisor and a friend to me. We have been associated with him for last 10 years. And with great love and affection, I welcome you, sir, Mr. Venkatesh.
Thank you. Thank you very much, Kaushik. Thanks. Okay.
Yes, sir.
Now I can start presentation, no?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Oh.
Yes, sir.
Hello, can you see? Hello?
We can
Hello?
see. Yes, sir.
Hello?
Yes, sir.
So I can proceed now?
Yes. Is it possible to make full screen? If it is not, okay. If it is not possible, you can start. Yes.
Full screen ಆಗುತ್ತೆ.
Yes, sir.
One minute.
Yes, sir. Yes, sir. You can
No,
start. You can start.
Okay. Full screen.
Yes, sir. Yes, sir.
You can start now.
Yes, sir.
Hello, good evening, all of you. So, today's topic, I would like to cover different tests on aggregates and their relevances. Aggregate is a very big chapter because it occupies nearly 60 to 80% of volume of concrete in concrete. So let me start with aggregate. Means we have to first find out the source, origins of aggregate. Origin of aggregate plays a very important role in the preliminary selection of sources of aggregate for use in the projects. Basically, it is a geological study concerning petrographic analysis, which determines mineralogical composition, physical properties, and chemical stability of material, which will have direct impact on strength, durability properties of concrete. Of course, petrography examination is the first-hand and preliminary information for quality of aggregate available in the quarries, based on which many engineers can select sources of aggregate for their projects, or they can help them to modify their concrete mixes, or help them to modify their engineering designs with respect to the type of aggregates available in the nearby projects. There is a, as far as aggregate is concerned, there is some restrictions. We are forced to use the available aggregate near the projects only. Unlike cement, admixture, we cannot source aggregate from other sources. So it is very important. Further, it is very important because it occupies nearly 60 to 80% volume of the concrete. So when come to the origin, there are three types of rock. One is igneous rocks, sedimentary rocks, and metamorphic rocks. Igneous is basically a basalt, diorite, and granite are the examples of igneous rocks. Sedimentary rocks, limestone, sandstone, shales, and chert are examples of sedimentary rocks. What is igneous rock means? It's the molten minerals erupted during volcanoes from the bottom of the earth. So commonly, igneous rocks are commonly used in concrete aggregates. Of course, sedimentary rocks are limestone, sandstone, shales are examples. So limestones are probably the most used concrete aggregates in this group. Of course, limestones vary from hard, fine, like grain crystalline rocks to very soft and weak material like chalk. So hard limestone is generally suitable for use of concrete, but soft limestones are not to be avoided. So that means there are two types of limestones. One is soft and hard. Soft stone is not suitable for concreting. So there are concrete aggregates. Again, is sandstone. There are two types of sandstone. They can be used of concrete aggregates only if they contain quartz grains and cemented together with amorphous silica. But there are certain things which are bound with clay and they are not unsatisfactory to use in concrete. So sedimentary rocks, shales are generally unsatisfactory because they are soft and absorption. Cherts are hard and dense, but depending upon the silica minerals, they may subject it to severe alkali reactivity concrete. When come to the metamorphic rocks, it is a combination of sedimentary and igneous rocks. They are dense. Generally, they can be dense also, but they can be weak in certain planes also, like marble, quartzites, granite, phyllites, etc. are the examples of metamorphic rock. So how it contributes? Aggregate originally viewed as an inert filling material, but later on its contribution and important in many folds was realized later in technology development stages of concrete. Today, the concrete is not just the filling material, it is a backbone of strength, durability, and other properties of concrete. The topic today mainly focuses on various tests, their requirements, and specifications relevant to the type of concrete produced, keeping the interest of durability, strength, durability, exposure conditions, weathering conditions, etc. So, there are three types of aggregates. One is natural sands and gravels, crushed rock sands, manufactured sands. Natural sands and gravels, they're basically from riverbeds. Present, of course, they're not allowed to use in construction. Crushed rock is a source from hard rock quarries. It is obtained by blasting, drilling, and they are screened also. It's only as such aggregates cannot be modified, their properties. The only modification that can be done with aggregate is cutting into proper sizes, shape, and sizes. That's all best can be done with aggregates, because other properties are depend upon the parent properties of the rock from which they are sourced. Nowadays, even this there's a demand for manufactured aggregate also. Manufactured aggregates, they basically the byproducts of industrial process, such as blast furnace slag. In that, there are different type of furnace slags. One is iron blast furnace. So it is a slag. It's a metallic byproduct produced in an iron blast furnace. It essentially consists of silicates and calcium and aluminates and other bases. By changing the cooling condition, cooling rate, the molten slag can be converted to solidified into a number of different forms. Most of the slags are derived from iron blast furnaces, but there are copper flags also has been used as a concrete aggregate. Air-cooled slag, granulated slag, foam slag are some of the typical examples of iron blast furnace slags. So I will not go much detail into it. There are lightweight concretes like expanded clay and shales. It is manufactured from clay and shale, heated about 1200 degrees. And when begin to melt and fuse and melt, some gases are generated, and which expands and forms honeycombs, forming small cells in the aggregates. So sintered fly ash is a typical fly ash, opening from fly ash with the water, coal slurry, and sintering with the picture of the overflow. Hello? Hello? Advantages, and we have to know, understand that some disturbance is there. Hello?
Mr. Prasad, can you please mute your mic? Thank you.
So there are some advantages and disadvantages of using slag in concrete. First of all, iron slag is a high strength and good for road construction for slabs, subbase, and bases. However, slag containing free calcium oxide and magnesium may cause delayed expansion, leading to potential cracks. This is a disadvantage of using iron slag. Air-cooled aggregates are generally porous, reduce workability in concrete. It may cause early shrinkage and affect durability. This is the negative aspect of air-cooled aggregates. Stainless steel stock is not recommended in RCC because of it affects the volume instability or may cause corrosion if not treated properly before. Copper slag is a heavier slag, not suited for low density concrete. It can improve workability but can segregate concrete. These are the advantages and disadvantages of some of this one. Manufactured sand. These are not categorized under natural types of aggregates because aggregates are not sourced from natural source. Instead, they are obtained from certain processes. Manufactured sands are not allowed in processing works, basically because their angularity shape can make the concrete harsh, low workable, produce inconsistent mix. These properties are particularly critical for concrete of grade M30 and above. So the permanent replacement of natural aggregates by manufactured aggregates as per is given in the following table. See IS 383 2006, it has given certain guidelines to replacement percentage of slag, manufactured slag. This is, you can see in this, it is displayed here. Say iron slag, steel slag for coarse aggregate, recycled concrete. It has specified certain limits for plain concrete 50%, iron slag, for reinforced concrete 25%, lean concrete 100%. Like that, it has limited certain percentage. There are reasons for that. Some of the reasons I'm going to highlight here. So replacement of iron slag aggregation RCC limited to 25% in RCC works. This is because higher replacement can lead to slow gain of strength and demand for extended period of curing. This is a disadvantage with iron slag. Steel slags are not allowed to use in concrete in RCC work as per this table. This is because calcium and magnesium oxide present in the steel slags can lead to expansion, cracking, and spalling of concrete. Sometimes they may even lead to corrosion problem. So these are the disadvantages with respect to steel slag. Indian standards also restrict 20% replacement only up to M25 grade concrete using recycled concrete aggregates, but do not permit to use recycled aggregate either in PCC or in RCC work. The RC means recycled concrete aggregates, generally porous, high absorption and low strength. The problem of other than concrete recycled aggregate, the problem is with porosity and risk of contamination and high risk of shrinkage. That's why they're not allowed to use in some cases. And when we come to the fly ash, the bottom fly ash is generally porous and have pozzolanic properties, and they are recommended only for lean concrete. So it is recommended only for lean concrete, that too with a maximum percentage of 25%. In fact, if you go to the IRC 749070, it allows only the Portland cement for road and pavement, but do not allow the use of fly ash in concrete. In lean concrete, restriction of concrete slag for a fine aggregate is restricted to 50% maximum. This is because the copper slab is generally contain traces of heavy metals like arsenic, lead, which makes concrete unstable. Also, it causes delay setting time, increased flow, sometimes leading with bleeding and segregation. Basically, their specific gravity is more than 3.3, 3.2, 3.4. So any replacement beyond 30-40% can reduce the strength of it. It not only reduce the strength of a concrete, but also leads into segregation because of its high specific gravity properties. What is the contribution of aggregates in recommended test? Basic requirement is that concrete aggregate provides strength, stiffness and durability to concrete, reduce voids in concrete, thereby reduce porosity and also increases strength, lower cement content in the concrete mixture, ensures dimensional stability of concrete, improves durability against weathering, abrasion, chemical and other abusive attacks, improves workability, pumpability and finishing properties of concrete, and controls shrinkage strength. These are some of the main contribution of aggregates in the concrete. Routine test. Now we'll come to the testing part. What I discussed so far is the basic properties of aggregate, sources of aggregates, and different type of aggregate and where it can be used and other things. Now we are coming to a routine test on aggregates. C1S is and combined grading. Proper grading and combined grading ensures no voids in concrete. Basically, it is done to ensure there is no voids in the concrete. It improves proper grading, improves strength, durability, and reduces permeability in concrete. Specific gravity and absorption. It is a measure of density. It is required in the design mix calculation for proportioning the design mix. And of course, moisture correction, moisture is necessarily required because all aggregates in concrete are designed for aesthetic condition. Aggregate impact value decides the resistance of coarse aggregate to sudden shock. Essentially, the test is required for pavement and road construction. Aggregate crushing value decides the resistance coarse aggregate to crushing under gradually applied compressive load. This test also measures the strength of coarse aggregate to compressive forces. 10% fine value test. It is an accurate alternate test to aggregate crushing value test when dealing with aggregate suspected which are easily crushed under small loads. Then coming to low flanges separation test, measures waste and resistance aggregates in roads and pavements and industrial floors. Shape test includes flakiness test, elongated test. These parameters affect workability, strength, and when they are flaky and elongated and non-angular. So they affect their they influence on workability and reduce the strength of the concrete. Soundness test determines the resistance to weathering actions, alternate wetting and alternate freeze and thawing actions. Deleterious and organic impurities determines the limit these two harming materials present in aggregate which affect the affectability, strength and durability properties of concrete. So these are the listed about. Or there are some more tests like alkali aggregate reaction, which in aggregate affect long-term and premature failure caused by internal expansion and cracking of concrete. Silt and cake test. It inhibits cement hydration and weakens the bond with the cement. Mortar cracking properties. This test helps in ensuring proper mortar workability, reduce cracking, and improve durability of masonry and plasterwork. Bulking of sand. Of course, it is required mainly for in a volumetric proportion. One is a performance test like models of velocity, thermal expansion. I will brief some of them with some examples. So what is the primary requirement of aggregate? It should be clean, strong, durable, angular, rough, cubical in shape, well graded, free from silt, clay, etc. This is as per they are given in Indian standard specification. In addition, they have to resist the abusive forces. Okay, they are subjected to during a surface life. It can be high weathering conditions or something like that. Sorry, one minute. Some of the type of aggregates are discussed here. See, the purpose of, fundamental purpose of grading of aggregate. See, all concretes are designed for dense concrete. That means 20 mm, 12 mm, sand, cement are used. Actually, the purpose of providing 12 mm is to fill the gaps which 20 mm cannot fill. And sand fills the gap, the remaining gaps within the 12.5 aggregate, and which is not again filled, it is filled by cement or cementitious material. So make it, the purpose of grading is to combine all these aggregates so that there is no gap in the concrete, inside concrete, and it is a dense concrete. Fundamental purpose of grading is already discussed, is to produce dense concrete. Concrete is basically a mixture of iron, cone, and aggregate. I already explained to you. Suppose if there are 12, there are in constructed 20 mm aggregates are available, 12 mm aggregates are available, but we require a proper grading. So in case, because they are individually they are not provide any grading requirement, so they have to combine. They have to combine in such a fashion that so they have become a dense concrete. Grading also influences the water demand of concrete and subsequent tendency to bleed and segregate. Okay, this is the grading. So maximum size, we have to understand the maximum size of aggregate, nominal size of aggregate. Maximum size of aggregates is the smallest sieve through which 100% of aggregate passes in the sieve. Nominal size of aggregate is one sieve larger than the first sieve to retain not more than 10% of the material. So this is called, what we are considering in the design mix is the nominal size of aggregate, because we are allowing about 5 to 10% higher size aggregate also. That is very, very important. Next is, so gradation part is over. Next important question is density, specific gravity, and water absorption of aggregates. The problem in concrete is it is backed by weight, but unfortunately it is supplied in volume. So it is supplied in volume. The conversion factor depends upon the specific gravity of aggregates. All aggregates and water, cement, etc., what are used in the concrete mixes. So the conversion makes some yield differences. See, one thing that if you take a natural aggregate, suppose granite, as per this, for geologically, its specific gravity is about 2.9. But we do not consider 2.9 design mix because we are considering the voids within the aggregates. So that's why the aggregates specific gravity is about 2.65 to 2.7 is normally used for granite aggregates. So 2.9 aggregate is the actual aggregate of specific gravity of aggregate from geological point of view. But for design mix purposes, where we have to consider the voids also in between the aggregate, we consider specific gravity of around 2.65. See how this yield is affected. Both are same weight, but the Bangalore type aggregate, you can see it occupies extra volume because the specific gravity of Hosur type of aggregate and Bangalore type of aggregates are different. See, this is a typical examples I have given. By using this absolute volume method, a typical example I consider is 800 kg of aggregate. So by using Hosur type of aggregates, the volume is about 0.296. 0.296 is the volume of Hosur aggregate, and 0.3 cubic is the volume of Bangalore aggregate. So the difference in volume is 0.2 is about 0.004 cubic meter per cubic meter of concrete. So by just changing our Hosur type to Bangalore type aggregates, there can be a per cubic meter, there can be a volume difference of 0.004 cubic meter. It is only for coarse aggregate. I have made a study of a typical mix design. One is Bangalore source aggregate and Hosur aggregate. These are specific criteria considered. In the concrete mix, total volume with Bangalore aggregate is 0.997 using absolute volume method. Hosur type is 0.986. The difference is 0.011 cubic meter per 1 cubic meter of concrete. Suppose there is a 50,000 cubic meter concrete is used in the project. It can, the difference can be about 550 cubic meter. So you are paying for 550 cubic meter extra by switching over to Hosur type of aggregate, which is have got a higher specific grade of aggregate. So there is a loss to be considered. So we had explained this kind of problem when we faced in Bangalore. Suddenly we had to change the sources and we started getting this difference and loss also. So that's why I thought I should share all this details to you. So specific gravity of aggregate is very, very important. It is better every 6 months or 1 month you recheck the specific gravity in the concrete mixes. Even water also contributes more. Of course, water is not comes under part of aggregate, but is a part of concrete mixture. What happens to water? You are designing the mix in the RNC plant. You are considering certain water, let us say 175 liters. Its volume is about 1.175 cubic meter. But during transit, it will lose some moisture because of evaporation losses. It can reduce to 165 liters. So there is a loss of about 0.0001 cubic meter concrete. Because I will not go much detail into this water aspect, but I will just give an example how this mixes change because of specific gravity and water losses. In design mixes, we are considering the 3 types of woven dry, saturated, and surface dry. See, the first one is woven dry. There is no, neither in the inside aggregate, there is no moisture, nor outside also. In saturated, there is a moisture fully saturated, but there is no moisture on the surface of the aggregate. Wet and saturated aggregate. For design mixes, we are considering only saturated and surface dry concrete. So this is very, very important. So grading requirement of aggregates, IS standard has given some limits for single size and aggregates. See, what is more important is, of course, for coastal fine aggregate also, it has given something. What is more interesting here is, Indian standards allows for 20% passing in 150 micron sieves. But see, normal for river sand, it allows only for 10%. 10%. Basically because the aggregate crushed aggregates are angular in shape and they do not smoothly pack inside the concrete. See, river sand generally is a round, it fills up the voids very easily. Whereas crushed sand is angular in shape, it will not fill. That's why code has permitted to use a little extra sand so that there's no gap in the final particle gap in the final in the lower sieve sizes, and it is also help higher the 150 micron percentage of fines means it also helps in pumping of concrete. This is typical exam of one is left one is 20 mm and aggregate. This is a 12.5 mm aggregate. Just to give an example, I will not go very into this because you're doing it almost every day. So these are combined against typical 20 mm 25. 55% of 20 mm passing through I consider. Humidity percentage was of 20 mm. This is 12 mm. This is 20 mm, 55% of 20 mm I consider, 45% of 12 mm consider, and I have arrived at the combined grading, which is satisfying the IS requirement. This is how combined gradings are done most of which you must be already in practice. What is more important in pumping concrete? Of course, Indian standards, if you go to the Indian standards, for pumping concrete, it asks you to reduce the 21 phase aggregate by about 10%. But if you go through some ACA 3.4, 2 or standards, it gives a specific grading starting from higher size aggregate to a combined grading. This is the combined grading aggregate. This is the boundary line. Up to 10 mm, there's not much different, but after 10 mm, it expects the same percentage passing. So this is how we can design the concrete mixers also. Of course, IS code gives a different method, but more I feel this is more relevant than IS standard. This can be thought of. This IS standard you can note. We say 304 216. Very interesting code. Of course, aggregate impact value. It is allows for 30% for use in for non-wearing surfaces. Non-wearing, basically this 30% for roads and pavements. So there's a procedure given in the IS code how to do it and all that. So I will not go very deep into it because this methods is already available and is known to me, most of you. Similarly, mechanical properties like crushing value, 30%, and aggregate for aggregates in case of 10% fine value. Okay, these are the tests recommended. These are tests recommended in the IS code. So 10% fines is very, very critical for in roads and pavement construction. That has to be taken care of. Abrasion value also he has given. So the procedure I am not going to go deep detail into it. For non-wearing surface it is 30, wearing surface 30%, and non-wearing it allows for 50%. So as far as IS code standard new Qcrete 3.216 is concerned, it demands for additional for slag, like for iron and steel slag, it accounts for calcium oxide, sulfur, iron, etc. Has given the limits of also. For copper slag also it is given. These limits they are given. Basically, see that there is no harm in if you use more than that, there can be harm in terms of cohesiveness or segregation or active chemical reaction, etc., etc. So with with lot of study, they are limited to this requirement. This is for copper slag. This is for steel slag. These are the requirement as per standard. For manufacturing also it has given, like it contains alkali content, sulfate content, acid soluble, water absorption, etc., etc., etc. So this is another for additional requirement for electric furnace acceleration slag. So these are various types of additional steps are recommended, especially for slag concrete. So that was not there in our previous 1973 code. Because nowadays additional slag also people are planning to use. So when you come to for plastering, there's a IS code, separate IS code for 1542. It gives a limit for clay, silt, and organic for some certain test and all that. The problem with sand is it may not be right quality of sand. It's very difficult to get. Of course, based on practical experiences and previous studies, some flexibility can be given. That is permitted in IS also, but it is the flexibility should not alter the properties of mortar. But in the course for concreting, there is no flexibility. Here some flexibility can be allowed for plastering and so, but we should not harm the concrete. This is for stand for plaster. There's a specification IS 1542. It gives a stand for IS designation has given. More than that, it also gives finest modules. Shall be not less than 1.4 in case of crushed stone, and for crushed gravel, it is given even finest modules limits also for plastering sand. So normally what we are using is generally normal. I have seen in construction they follow only IS 383 for concrete aggregate zone passing in zone 3 or zone 4, but it is not the right standard. For this, I suggest that people should go for these standards to find the right type of aggregate for plastering and this one. So this is first. Huh?
What is happening?
Yeah.
Many people ask for create instead of conflict.
Of course, this is for masonry mortar. 2116 is the highest stand for masonry mortar. These are limits are given. So this is all given in IS code. Only thing you have to go through this IS code 2116. Very important. This is for how much clay content, organic important contents, etc. Also given in IS this one, that also can be referred. And selection of aggregate for plastering, IS has given a separate method. 2250 has given a method how to find whether this aggregate suitable or not. 2250 has given a method to find out a particular method in what whether sand is suitable or not for mortar. So it's specific for minimum 3 Newton per millimeter at 28 days strength. It's a procedure available. Please go through that 2250/1981, based on which you can select the type of aggregate for plastering purpose. If it is good, then it means that it is good for plastering. And is good for plastering. So this is how we have to take decision. When it comes to the mass concreting, I understand it has given certain guidelines for designation. What should be the percentage of grading of aggregate, post and fine aggregate, post aggregate. These are guidelines, just a guidelines. You can. This is also given IS 383 2016. That can be referred to. Elongation, frequency elongation, total is not be, let's say, 40%. So earlier, previous code it was not there. Now it is there. Given is 40% is the limit for normal concrete. And when it comes to now, the grading is over now. Now come to the specific gravity is over. Now we'll come to the shape of aggregates. See, these are the typical shape: round, irregular, regular, flake, elongated, flake and elongated. This is the typical shapes of aggregate, describing all these things. See, angularity number plays a very important role, especially in road work and construction. See, angularity remains is the packing density of aggregate also depends on shape and angularity number. If number of spherical packed together in the space of the volume of solid will be. Suppose if you take only a rounded aggregates in a container, about 67% is only occupied by the aggregate, remains as a void, 0.3%. So aggregate angularity number decides it has counted from 0 to 1, 11. 0 means it's the angular means it's a rounded aggregates. Angularity number 11 indicates that most of it is a crushed aggregate. Ideally, angularity number 0 to 3 for high workable concrete, 7 to 10 for road construction, and 11 for construction of normal construction of buildings. These are the limits you can consider. It's not given in the highest standard, but it's a general based on literatures and studies noted. Some more I won't give now. So very interesting is that when you come to the question of self-compacting concrete, what is self-compacting concrete? See, we require difference between normal concrete and self-compacting is that in self-compacting concrete we require some extra paste other than what is really required for normal concrete. So what are the paste is required for normal concrete is also required. In addition to that, it also requires additional paste. See, that is can be decided from this expression I have taken from some research papers. This is the equation. How much extra is required? This is the formula. This RSA is a value depends upon. See, these are the things. Very interesting. You can see. See, RSA value can be for shape, angularity, and examples also is given. If this is the shape, typical shape, you can have to take 1. If this is the one, you have to take 1, 2, 2, 3, 3. So you can from the shape, you can decide this number and go back to the previous, apply here, and you can from this formula you can see how much extra paste is required in self-compacting concrete to give a very flowable concrete. So this is not given in any of the standards. I have taken it from some research work, and that is I'm finding it very informative, and I used in designing many of the self-compacting concrete using this guidelines. So recommended number of angularity number, RCC 7 to 10 for a good bond, adequate strength and good workability. High strength 8 to 11 provides higher interlocking and better load transfer. 9 to 11 for skid resistance. This is the best for skid resistance and concrete stable under traffic. Pumped concrete 4 to 7, mass concrete 3 to 6. These are recommended angularity number. Of course, again, it is not given in the standards, but it's a general norm based on literatures, many of the literatures. High angularity means increase in water demand, low workability. Very low angularity means reduction in strength and bond in concrete. Reduction in strength and bond. So low workability number means like rounded aggregates. Its bond is poor, so the strength is also not good. Whereas if you want a very high limit, high low workability, increase in water demand. So these are some of the way you have to think. Now we come to the sound test. We are doing this test is conducted by immersing the aggregates in sodium and magnesium sulfate solution for a specific period of duration. Okay, this is very critical in freezing and thawing actions of waters in aggregate. I will explain you one with the photograph also. See, what we have in the pop-outs, especially this in pop-outs expansion of porous low density concrete, high rate of absorption. This occurs such as shale, coal. This type of pop-outs occurs in freeze and thaw action. Very important. The offending of aggregates absorbs moisture and freezes under the one. What happens? These aggregates absorb moisture. When it freezes, it exerts the swelling pressure. It is more than 9% more than water pressure. So that much swelling, it exerts pressure. And when it exerts pressure, the aggregate starts breaking. So the top portion of the aggregate fracture separates from the concrete surface. A typical one I have shown here. See, this is the type of it. See, this is the aggregate because of popping. It also takes away some water from the concrete. So it happens basically because of freezing and thawing action. It's a soundness. The soundness test is very critical for especially for freeze and thaw action, because it gives indication of how aggregate behaves with excessive pressure induced from freezing and thawing action and any expansive nature of forces materials in the aggregate. So these are the soundness tests. Sorry. So these are the requirement of soundness test. Again is given in the highest code. I will not go very deep into the specification. It's already available in the standards. This is also available in the limit for literacy is available in the IS 383 standard. This is also, I'll not go into deep because you day-to-day activities, you must be following all these things. Now coming to the alkali aggregate reaction. This is a very important. See, alkalis in the form of sodium oxide and potassium oxide present in cement reacts with certain silica present in relative silica present in the aggregate causes alkali aggregate reaction, affecting it increases the volume, and you can see this type of cracks formed by alkali aggregate reaction, very critical. See, Indian standard has given some method, petrographic ignition, prism test, accelerator mortar test, etc. They have got their own advantages and limitations also. For example, if you go for concrete prism test, it takes about 1 year to decide. So until then, project cannot wait. Accelerator can be used, but it can sometimes give leading information, misleading information also. So petrographic emission is required, and IS code has one chemical method. So innoxious zone and noxious zone. So consider the innoxious zone, it has to be aggregate. When you do the chemical test, it has to fall in innoxious zone. So that, but there is a limitation with this test also, because containing it will not effective for aggregate containing carbonates and magnesium silicate. Hence, whenever you do this test, spectroscopic study is also very important. So only this test, chemical test, along with spectrography test is also required. So limitations, prism times, lengthy duration, not suitable immediate project schedules, rapidly measures the silica reduction and calculation, poor reliability of certain aggregate type fails to produce acceptance criteria. Chemical method, user higher temperatures, strictly and pressures for rustling. Result can restore some due to leaching effect and when non-repeat sands are used. So misleading and these are there some disadvantages of these tests. So basically, when you give it to the third-party laboratory, they will able to help you out. This is just a general information I am giving. So as I told you, then we come to the question of mass concreting. So another 10-15 minutes I'm going to give you lectures. Mass concreting basically is what is more important is rise of temperature inside the concrete and how fast it dissipates inside core temperature to outside. So here development of inside temperature first should be controlled. That is possible with less cement content. Less cement content is possible only with higher size of aggregate, which requires less cement content because of its coating required relatively coating surface is relatively less in higher size aggregate than lower size. In lower size, more coating has to be done with cement. More cement coating means more cement content. More cement content means high release of temperature. So it is higher size aggregates are desirable in anything. Then there are two important factors to be considered in mass concrete, high material loss density See, this is expansion, high modulus and high coefficient thermal coefficient. These are the two factors which affect the thermal stresses in concrete. Higher modulus of elasticity means concrete is stiffer and more rigid. So a stiffer concrete cannot easily deform to accommodate thermal modulus changes, leading to higher tensile strength. So higher modulus of elasticity exert higher tensile strength, and it's a great chances of cracking is more. Higher thermal coefficient of expansion. Okay, expands more when hot and contract more when less. See, when they are combined, temperature stresses are found using this equation. So, see, the thermal stresses in mass concrete depends upon this equation. It also depends upon the thermal expansion of aggregate. See, limestone has got, this is a chart for thermal expansion for limestone, granite, air-cooled slag. This is a typical this one. See, higher the coefficient of thermal expansion, lesser the coefficient means lesser the thermal coefficient. Higher coefficient means higher the thermal stresses, resulting in more drying shrinkage crack. So the most problem in mass concrete work is the expansion due to drying shrinkage. So other two important factors to be considered is thermal conductivity and thermal diffusion. Thermal conductivity is a measure of rate at which heat flows, that is how quickly heat moves from one inner core to surface of concrete. High conductivity means transfer of heat is faster. High conductivity means it's faster conducting the heat. Thermal diffusion, it is the rate at which temperature change occurs within the mass and quickly equalization of temperature takes place within the concrete, which is essential for reducing the temperature difference. Both these are important. That means higher thermal conductivity and higher thermal diffusion means faster dissipation of heat into the concrete. So these are some properties of thermal conductivity and thermal diffusion. So quartz, dolomite, etc. they are given for convention. So you have to choose the right type of aggregate. Unfortunately, what happens in project, you are bound by you are forced to use the only available aggregate site. To, if possible, if you can procure some distance also, okay. If not, you have to contract with some other measures, like using low heat cement or use ice water or ice in concrete, etc., etc. Now we'll come to industrial flooring. Fine aggregate should not be used for weathered rock, should not be used. Okay. Crushed aggregate can be used. And fine aggregate should be on the zone 2. Use of lightweight are not recommended as they generally offer least resistance to abrasions. So it's not. And given a typical example, the corundum and andesite aggregates to over 3 to 4 more wear resistance compared to pure cement mortar, and 2 times more resistant than mortars prepared with dorite, domalite, quartzite, and granite aggregate, and 20% mortar prepared with decomposed granite. And so from this, I'm just giving an example. Corundum and andesite aggregates are much suited for industrial flooring aggregates. Fine aggregates, of course, only in fine aggregate, what you have to import is that silica content should not be less than 40%. If you want screed resistance, it should not be less than 40%. See what happens in industrial flooring. The first, the top layer is only with fine aggregate. In the floor of the slab is the fine aggregate and cement. Below that, coarse aggregate will be there, which means that first of all, the fine aggregate is very important. because it is the first one, it has to offer resistance. Once it wears out, the coarse aggregate below come into action. So aggregate is very, very important. And another thing is, aggregate can be best resistance abrasive forces, need not be best resistant impact loads also. So one has to see that you cannot say that it is good abrasive aggregate is also a good resistant impact. It's not correct. Basically, hard aggregates are brittle in nature and easily fracture under impact. So it's a brittle aggregate. On the other hand, soft aggregates which are resilient in nature absorbs impact loads better than the hard aggregate. So the type of aggregate for industrial flow should be amicable between the two type of aggregates. Again, it is, as I told you, there is restriction because we are forced to use the aggregate available in the nearby source. But in each case, you have to go for if you other methods like flooring, giving floorings, different type of floorings, etc. Means of okay. So these are the typical lower water cement ratio, improves the strength and abrasion resistance, should be designed for least void content. Coarse aggregate should not be 30%. And more thing is shrinkage. It should be less than 0.005% as per this. These are the properties of aggregate. You have to use it. And load required for 10% fine in a coarse aggregate should not be less than 150 kilonewton. Soft aggregate should not be used. Weather should not be used. So if nothing is possible, you have to go for alternate material like in using steel fibers or other deficiency you have to make up with the flooring, floor coverings, etc. Now we'll come to the drying shrinkage of concrete. Effect basically drying shrinkage. Aggregate has a very important role in aggregate cement ratio. Plays a very important role. See, higher the aggregate cement ratio, that means lower the aggregate cement ratio means higher the cement content. This is the crack, higher the decay shrinkage. This is lower the shrinkage. So aggregate cement ratio plays a very important. The problem with the shrinkage is drying cracks are basically caused due to water content in the loss of moisture from the cement bed, which can shrink by as much of 1%. So cement can 1% shrink can happen, but aggregate by using suitable aggregate cement ratio, it can counter by about 6.06%. You can reduce the shrinkage. So higher these are the things you have to take care of. So we have to use aggregates of higher size aggregates, use less cement for drying shrinkage cracks, and certain type of aggregates also influence them. Suppose you're using sandstone, its shrinkage is 0.00%, limestone is 0.0. If you have a choice, you have to use limestone to counter shrinkage because it's almost between sandstone and limestone is the ratio is almost 2. So these are the guidelines I can give you, but it's only for informative and how best you can use. You have to think about it. Now, aggregate plays a very important place in joint space in industrial floors. See, industrial floors, you are providing contraction joints to take care of tensile, curling, and wrapping stresses. The other name given to contraction joint is a control joint. ACI do not recommend a joint spacing 24 to 30 times slab thickness to control these stresses. The typical curling failure due to curling effect is shown. See how you can see the cracks here due to curling. How this corner, you can like this cracks, these are curling. You can see water is stagnated in this portion. Because curling means the corners lifts up. When the vehicle moves, it crushes. So basically for that, for industrial floorings, construction joints are provided, where construction joint allows for cracks to appear exactly in the construction joint below the construction joint. So what happens? Aggregates plays a very important role. Okay, and especially in right shrinkage. And see, aggregate interlock. Contraction joints that are placed at certain intervals also come from. See, contraction joints, what happens? Two slabs with joints, because there is a gap in the contraction joint, load has to transfer from one slab to other. So how it is possible? Because there is already a crack inside the contraction joint, is a crack. So transfer of load has to take from one slab to other when the vehicle moves from one end to other end. But how to transfer load? One is providing dowels, other is to provide aggregate interlock. Aggregate interlock plays a very important role. See what happens, it has got certain limitations also. You need not use dowels if, suppose if there is a advantage also, I'll tell you. Effectiveness of load transfer depends upon the vehicle load, driving load, slab thickness and spacing also. Aggregate interlocking mechanism is only effective for smaller loads. So see, when the special industrial floors, where only wheel loads, packing and etc. is there. And the joint thickness is 0.6 mm to 6 mm, and it depends on the slab thickness. The joint thickness of 0.6 mm in 230 mm thickness can effectively transfer 100% of the load on the other side. So there is a 230 mm slab thickness, and the joint is about 0.6 mm. It can pack 100% of the loads from one slab to other, for smaller loads and not subjected to lying loads. But if the joint width is more, say 0.9, it can transfer only about 60% of the load to the other side. So these are the factors. Of course, basic things one has to know about use of aggregate. It also decides aggregate and joint spacing of aggregate. See, why the aggregate plays a very important role, because slab thickness 100 to 250 are considered, stump of 100, 150 are considered, stump less than 100 mm. Two factors I consider. If aggregate is less than 20 mm aggregate, it requires 6 meters spacing of contraction joints. If it's 100 thickness, 2.4 meters, 125 and 3.4, like this, goes on increasing. For higher size aggregate, you can increase the to 7.5, 2.4 to 3, you can increase 3 to 3. That means joint spacing can be increased by using taking advantages of sizes of aggregates. So if when the slump is less, this is the spacing. This is as per ACA 360 26A consideration. Then we come to the high performance concrete. The high performance concrete, what happens? Requires the required mineral composition, shape, texture, and grading. Mechanical properties as per standards is very, very important. More important, high performance concrete is the interfacial difference, interfacial phase between aggregate and cement. Aggregate and cement, because interfacial zone is generally a weak zone. So in high performance, weak zones are not permitted. It has to be made strong. So what happens? Transition. Use of coarser size of is not recommended in high strength. Coarse size not. Say larger coarse size is not recommended. Higher size of aggregates is not recommended in high strength and high performance concrete, because Larger size aggregate basically creates incompatibility in the transition interface zone between aggregate and cement paste with respect to model of velocity, Qcrete, submersion rate, and Poisson's ratio. Incompatibility may lead to development of micro cracks in concrete. So higher the size of aggregate, more than basically in the high strength concrete, ultra high strength in concrete, we never use a very 20 mm size aggregate. So there's a just misconcept in the equation. You have to get high strength means you have to get higher size aggregate. It's not true. Even ultra fine M200 grade concrete are not designed with less than 6 mm size aggregate. So very complicated. Basically because we have to make strong interface zone. I'll show you one typical photograph I've taken. See, this is the where I have taken for high performance concrete. So you can see that here aggregate. Breaking is taking place in aggregating. In the aggregate, where the aggregate actually in high performance concrete, the failure should take place through aggregate, not through cement mortar. But in normal concrete, we are allowed to break through cement, not through aggregate. But in high performance, you can see here how it is breaking through aggregates. It's very, very interesting. So you can also do some experiment at site and think of it. So flake and elongation should not be more than 10%. This is another requirement. It should be aggregate should be clean from clay, chloride, sulfates, etc. This is as applicable to normal concrete and zone 2. And fine sand aggregate. See, aggregate of sand should be of higher percent shows coarse material, lower percent on. So ideal should be 2.8 to 3% is the ideal fineness fineness to fit the for a high performance concrete. 2.8 to 3.2 is the range, but ideal is 2.8 to 3%. This is a typical example how aggregate influence the fire. This is calcareous aggregate. This one is calcareous aggregate. Siliceous aggregate. How it affects. Reduction, it shows how reduction in compound. So if you use siliceous aggregates, so reduction in percentage of strength is less, if you use calcareous more. So this is the guidelines you can take. So these are the type of when it comes to deviation density of concrete can be classified ultraviolet, lightweight concrete, normal weight. Based on the density, you can fix the uses where it can be used: thermal insulation, lightweight structural concrete, normal weight concrete, heavy weight concrete. These are the types of aggregate for various types of aggregate where it can be used. So what is the density of the concrete? These are some of the guidelines given. I think I have crossed the limit also. So at this stage, I would like to stop for open for further discussion with the Kaushik and team. Thank you.
Hello,
Hello.
sir. Good evening.
Good evening.
Hello. The audience can post their questions in the chat box, and we will pick the questions and ask to the speaker. Right now, this can be question answer session. Venkatesh sir. You have finished your presentation, sir?
Huh? Yeah.
Okay. Any questions are there? People can post it on the chat box, and we will post it to, we will ask our speaker to give an answer to that one. Okay. It seems not many questions are there. Not many questions are there. I think Andakumar?
Yes, sir. Until now we didn't receive any questions, sir. If you are not
Yeah.
unable to chat in chat box, you can raise a question in your QA box. And until now,
Do you
no one
find
is
any question, Andakumar?
Sorry, sir.
Okay. Sir,
Yeah.
we will try to conclude the session. Mr. Venkatesh, sir, we are thankful on behalf of Qcrete Readymix India Private Limited for accepting and coming on to give this wonderful lecture on aggregates and related tests and their relevance. And it is really an honor to us. We are extremely thankful to you, sir, for spending your valuable time in enriching knowledge of our audience. The lecture was exhaustive, interesting, and you gave a lot of information and guidelines for all QHC engineers, participants who are working in the field of concrete and who are interested in the field of concrete. Thank you very much, sir. We would like to have some more lectures with you in the future also. Once again, on behalf of Qcrete Readymix India Private Limited and Indian Concrete Institute, Mangaluru, we would like to thank you. And really, it has been a wonderful lecture on the aggregates, and really for many people, a lot of information, lot of new information, which probably is not available in many books or textbooks or whatever. We find the information was really amazing information and guidelines to do better concrete. Thanks a lot, sir. Thanks a lot.
I will be very happy. Thank you very much.
Thank you.
Anything missing, you can always tell me. I can upgrade it in future.
Thank you. Thank you, sir.
Sir, what about powder concrete?
Thank you, sir.
Okay.
Awesome.
Thank
Thank you.
you.
We once again thank all the audience who attended on this day. We would like them to join in our future endeavors also. Thank you. Namaste.
So I can close it now.